finding your assignments there. Okay. So they will either send you individually or just they will help you log in your portal. So the worksheet was about linear equation. That's only first worksheet I've uploaded so far. The rest of them I'll also upload. So that will help you in your exam. And for triangles also, I'm going to upload a worksheet today. Okay. So please do them. Question number 10. Okay, we have done. Now 11th we have to do. Fine. Now look at question number 11. What does it say? So in the given figure, 6.40, E is a point on side CB produced of an isosceles triangle ABC. Fine. So let me draw a triangle ABC. Isosceles. What is an isosceles triangle, Rida? What is the meaning of an isosceles triangle? Yes, please unmute yourself.
A triangle that has two equal sides of length.
Yes, so two sides are equal basically. So E is a point on side CB produced of an isosceles triangle with AB is equal to AC. So it is given that AB is equal to AC. Fine. If AD is perpendicular to BC, so this is also given, AD is perpendicular to BC and EF is perpendicular to AC. Okay, so prove that. To prove that triangle ABD is similar to triangle E, C, and F. Okay, which is ABD? Okay, the left one, and ECF. Fine. So this is a good question. It is, many times it is asked in exams also. And it's very simple. So I think we should start with the triangle which we have to prove to be similar and just let us find out how many criteria we are able to satisfy. Okay. So proof. Let us start with these two triangles only. So in triangle D and triangle EFC. So what is there, Rida? What can I write? Equal or something?
Angle ADB is equal to angle EFC because 90 degree.
Yes, it is given that they are perpendicular, so 90 degree. So angle ADEC, yeah, equal to angle EFC. Fine.
ADB.
AD. Okay, this triangle I want to prove. So ADB, yes. EFC. Okay, fine. And what else?
Ma'am, angle ABD is equal to angle ACD.
ACD. But C,
Ma'am, because the angles, they are the angles opposite to the equal sides.
yes. Yeah, because C is forming a part of this triangle EFC. And yeah, okay, very good. So angle B is equal to angle C. Why? Angles opposite to equal sides are equal. Yes, Rida? Angles opposite to equal sides are equal. So which criteria is?
AA.
Yes, so by AA criteria, triangle ABD is similar to triangle ECF. So it can be a very short question, 1 or 2 mark question, but it's easy. Now come to question number 12. So I'm just rubbing it. Have you written, both of you? I hope you have written. Yep. All right, question number 12 now. What does it say? Sides AB and BC and median AD of a triangle ABC. So first are respectively proportional. Okay, so basically I need two triangles here. Oh, figure is given 6.41. That's fine. Yeah, this is again a good question. A, B, C, it can be, a long 3-4 mark question. 3 marks it can be asked. P, Q, R, and then M. Right. First of all, write down whatever is given and whatever we have to prove. So you will tell me what is given here. Yes, Rida, what is given here?
AB by PQ is equal to BC by QR is equal to AD by PM.
BC by QR is equal to AC by, sorry,
AD by PM.
just a minute. Let me read the question. Side AB and BC and median AD of a triangle. Okay, AD is PM. Okay, median of a triangle are respectively proportional. Fine. Show that. So what you have to show, that triangle ABC is similar to triangle PQR. Okay, the full triangle you have to show to be similar. So let's do the proof. Okay, if I start with the given condition here. So let us start with the given condition that AB, or you take the triangle first of all, in triangle ABC and triangle PQR. So this is given that AB upon PQ is equal to BC upon QR is equal to AD upon PM, right? Okay, so this I can write like this, AB upon PQ. If I divide the ratio by half, will it make any difference here, Hamna? If I do it like this?
Yes, ma'am.
I mean, I can divide it by the same number in the both multiply by the same number in both numerator and denominator. There's no problem because half will cancel out. Ultimately, it will be BC by QR. Okay, now why I'm doing it? Because this will give me AB upon PQ is equal to, now what is half of BC?
BD.
BD is actually half, it's not very clearly visible in the figure. D is basically here. And I have not drawn it properly. That's the definition of median. Yes, Rida?
Yes, ma'am.
Okay, median is basically the line which divides uh,
And
the side into two equal parts. So by QM will be equal to AD upon PM. Now I take the small triangles, which I need to show similar. This one. Oh, no, sorry. Full triangle, I have to show similar. ABD and PQM. Yeah, what can I conclude from here, Hamna? If this proportionality is fulfilled, which triangles are coming out to be similar from here? Tell me.
ma'am, triangle ABD is similar to triangle PQM.
PQM, yes. That's fine, Rida?
Yes, ma'am.
Okay. Now, because these two triangles are similar now, so can I write that therefore angle B is equal to angle Q?
Yes.
Corresponding angles of this, similar triangles are equal. This you can write in the bracket if you wish, that corresponding angles of similar triangles. So just write it properly. Now I can take the big triangle. So in triangle ABC and triangle PQR, now I have AB upon PQ is equal to BC upon QR, right? Like two sides are in proportion and one angle is in proportion. Angle B is equal to angle Q. So therefore I can write that triangle ABC is proportional to triangle PQR. Is this clear?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah, because this was the problematic thing. It was not AC by PR. It's actually the median, AD by PM. So directly I cannot use Sas criteria here. So ultimately we have shown that these smaller triangles are similar and therefore one angle is similar. So because two sides were already in proportion, now one angle is also similar. So by Sas criteria. Yeah, sorry, criteria I have not written. So which criteria is this?
SAS.
SAS. And also please make sure that what is SAS criteria? If this angle is equal to this angle, then these two sides have to be in proportion. Getting it? Not the opposite one. So AB upon PQ is equal to BC upon QR. Is this clear, Rida?
Yes, ma'am.
I mean, these two sides I have to take. I cannot take this opposite one. The sides should be the one which is, between them the angle is there. So similarly here also. So this is satisfied here. Now next question, number 13. I hope you have written, all of you, both of you.
Yes, ma'am.
Okay. Now 13th question. Okay, figure is not given. See, these last questions are actually all questions you have to practice well. Most of the time, one of the question is asked in the exams. So D is a point on side BC of a triangle ABC. So first of all, draw a triangle ABC. Let's see. ABC. Sorry, ABC. D is a point on the side BC. So anywhere you can take, because I don't know it is median or not. So anywhere D. Such that angle ADC. So you have to join it. ADC, that means this angle, is equal to BAC. BAC. All right, this complete angle. Write down first of all what is given. That angle ADC is equal to angle BAC. To show CA square, CA square means CA whole square, right? CA multiplied by CA is equal to CB into CD. Okay. So how we will do it? I think I should take the two triangles where the angle is given. So one triangle I'm taking triangle ABC, right? And then this triangle ADC. Is that okay? Yes, Hamna. Now please try to fulfill some criteria and tell me what can I write here. So one angle is already given to be equal. Yes, Rida?
Yes, ma'am.
So angle angle ADC.
Ma'am, angle C is equal to angle C because it's common.
Okay, yeah, that will be common. Good. And one is already given because I'm writing ABC here. So I start with here. Angle BAC is equal to angle ADC. This is given. Okay. So that means the triangles are similar. So how to name the triangle? If I'm telling ABC is similar to
Triangle DAC.
Now how to name it? So which angle is equal? C. So I need C in the last, right? And then how should I write it? Hamna, please help me out.
Angle DAC. Sorry, triangle DAC.
Let us check. So AB upon DA. So AB upon DA. Yeah, I think it's okay, Rida. Then BC upon DC. BC upon AC. Basically, this BC is opposite side to angle A, right? So and AC. Yeah, no, it's fine now. So triangles are similar. So therefore the sides are in proportion. So now I can write. So that means this BC upon AC, right? So I can write BC upon AC, clear? Is equal to, then what I need, CA. See in the, here, I need CA. So CA upon, now what should I write here?
DC.
CA which side, which side? DC. Is this clear? See, which is BC? BC is the side which is opposite to the angle. And AC is the side which is here opposite to this angle. Clear? You can do one thing. If the triangle is causing some confusion, you draw it like this. And you draw separately, like that's a rough part. Clear? So if you are taking this ABC, yes, Hamna?
Yes, ma'am.
Okay. Now because angle A is equal to angle D, so you are taking D here. And then this will be your A and this will be your C. A, B, C, and oh, sorry. This is B. Now check with this whether this is satisfied. So BA upon AD. So BA, what have I done here? Hamna, please help me out. Wait. Is D, right? Okay. A, B, C is this, and I'm taking, so C will come here and A will come here. I think this is fine now. So now you can check that BA upon AD, BA upon AD, yes. AC upon DC, AC upon DC, yes. Yes, Rida, actually BA is actually corresponding side is this one. Understood? And this
Yes.
corresponding side is this corresponding to this. Okay, that's how the figure is now. So if I write BC upon AC, okay, fine. Then CA upon DC. Yeah, I think that's fine now. Any confusion here, Hamna?
No, ma'am.
Yeah, because I'm taking CA, that means this side, so I have to take this one. I hope it's clear. Now this is also AC and this is also AC. So if you cross multiply, so BC into DC is equal to CA into CA. AC and CA are same, clear? And you can also change it to be like if you want to make it look similar. So BC is actually CB and DC is actually CD is equal to CA whole square. So proved. So it's a simple question. Just the figure is a bit, you have to observe it carefully. Just to name the triangle is the trick here. If you name it properly, so you can do it. So it's better you split the figure and then you will be able to see it clearly. Rida, any problem here?
No, ma'am.
Okay, please note it down. Then I'm going to question number 14. Hamna, have you written?
Yes, ma'am.
Okay, question number 14 now. Sides AB and AC and median AD of a triangle ABC are respectively proportional to this. Okay. Oh, which question we have done right now? 13th. Yeah, 14th now. So basically you need two triangles here. And one more. Okay, one is your triangle ABC and other is PQR. And he's talking about median. So let's say this is median D and this is median AD and M. Okay, this is M. Right. Now, whatever is given, right, side AB, AC, and median are respectively proportional. So we can write AB upon, yes, Amna, tell me, PQ is equal to AC upon PR, yes, is equal to
AD upon PM.
AD upon PM. Okay. Yes, Rida, this is given in the question that they are proportion.
Yes, ma'am.
Okay. Show that, you have to show that triangle ABC is similar to triangle PQR. Okay. How to do it now? Proof. Mm, we can do one thing here. We can make a construction. So before proof, let's do one construction. Now construction is that I'm going to draw a line DE parallel to AC, right? So this line is actually parallel to this one. Getting it? So draw DE parallel to AC. Yes, Frida?
Yes, ma'am.
Okay. And similarly in the other triangle also. So draw a line. Let me call it S. And so your MS is actually parallel to PR. So that I can make use of basic proportionality theorem. That's why I'm drawing it. So now let's do the proof. Now see triangle ABC first. In triangle ABC, okay. So it is given that AD is a median. Clear? AD is a median means D is midpoint of BC.
Yes, ma'am.
Yes. So D is the midpoint of BC, and then DE is parallel to AC by construction. So there's a theorem which says that E is also the midpoint of AB by basic proportionality theorem.
Converse of midpoint theorem.
See, what is a converse of basic proportionality theorem? That if line DE is parallel to AC, clear? So that means the sides are in proportion. So ultimately your BD upon DC is going to be equal to BE upon EA. This is the converse of BPT, yes? Nobody will speak now. By converse of basic proportionality theorem, can I write Hamna like this? Because my line DE is parallel to AC. So by converse, can I write BD upon DC is equal to BE upon EA? Is that okay?
Yes, ma'am.
Okay. Now, no. Wait. I cannot use BPT here. Let's do it different way. Just a minute. Let me do it. Please don't write. I'm just do it like this. We will use BPT later on. See, D is the midpoint of BC, right? Again, look here. D is the midpoint of BC and my line DE is parallel to AC. Yes. So can I use midpoint theorem here? By midpoint theorem. What is the midpoint theorem, Rida? That if a line is parallel and one of like midpoint theorem is this. Please recall that if my line, for example, DE is parallel to BC, okay, and D is the midpoint of AB. So ultimately, E is also the midpoint of AC. That's the midpoint theorem. Yes, Frida, are you able to remember that?
Yes, ma'am.
Hamna, is that okay?
Yes, ma'am.
Okay. So two conditions are here. So D is the midpoint of BC and DE is parallel to AC. So by midpoint theorem, E is also the midpoint of AB. See, by BPT, what I'll get? By BPT, I'll get BE upon EA. Yes. This will not show me whether BE is equal to EA or not. It is only telling me the proportion. Getting the point here?
Yes, ma'am.
I actually need BE to be equal to EA. So that is why I'm using midpoint theorem here. Understood? Okay. So E is also the midpoint of AB. So that means yeah, and midpoint theorem also says that this side DE is actually half of BC. That was the statement, Hamna, if you remember from last year.
Yes, ma'am.
Yeah. So if a line, parallel to the 1/3 side of a triangle and intersect the other point, line, then this is actually half of its length. That was the theorem. You can just go back to class 9th and revisit midpoint theorem again. So this will give me that my DE is actually half of AC. Yes. Okay. So in one triangle, I have shown that DE is half of AC. Similarly, in the next triangle, I can show that my SM is actually half of PR. So far, is this okay, Rida?
Yes, ma'am.
Okay. All right. So please write it down so far. Okay, now start with the given condition. So we are given that AB upon PQ is equal to AC upon PR is equal to AD upon PM. Actually, I'm going to use these two results now. Now AB, how can I write AB this time? Can I write it twice of AE? Is that okay?
Yes.
And similarly, PQ, I can write twice of PS. So basically, I'm making use of these results. So this is equal to, now AC, how can I write? AC, can I write twice of
2DE.
Twice of DE, yes. And similarly, PR, I can write twice of SM. And this is equal to AD by PM. Okay. So 2 will go out now. So I'm left with AE upon PS is equal to DE upon SM is equal to AD upon PM. Right. So which triangles are now similar, Hamna? Tell me. Basically, this triangle, this one and this one, they are now similar, isn't it? If you look at this thing. So A, E, and D will be similar to, so AE upon PS. So I'll start with PS here and then I'll write the other one, PSM. So far, is that okay? By SSS. Is that okay?
It's PMS.
PMS. Let me check. AED. It should be PSM. Vrida, why are you saying PMS?
Because AD is equal to PM.
No. See here. The way I told you how to write, you are getting the proportion AD upon PS, right? That means the side AE is proportional to side PS. So if you are writing AE here, so you will use PS here.
Okay.
Yes. Yes, Hamna, okay so far?
Yes, ma'am.
Okay, so now let me. So I hope you have written here so far. Okay, so if the triangles are similar, then some angles are going to be similar. Let me give some names to angles. This angle will be equal to this one, clear? And this angle will be equal to this one now. So let me call it 1, 2, 3, 4. Let me give some names, or X, Y, whatever you want to give. So therefore, this implies that angle 1 is equal to now angle 3. And similarly, angle 2 is equal to angle 4. Right? Corresponding parts of similar triangles. So if you add them, angle 1 plus angle 2 will be equal to angle 3 plus angle 4. So 1 and 2 means complete your angle A, and 3 plus 4 means your complete angle B. Yes?
Yes, ma'am.
Okay. Because if I want SAS criteria, so at least one angle I need equal. So far we have shown that one angle is equal in both the triangles, and the two ratio were already given. So by SAS criteria, now they will be similar. So now in triangle ABC and triangle PQR, so this is given that AB by PQ is equal to AC by PR. Yes, Hamna? This was given to us.
Yes, ma'am.
Okay, and one angle we have shown that angle A is equal to angle P. As criteria, we can write that triangle. Now name it properly. If I'm writing ABC, will be similar to triangle. So angle A is actually equal to angle P. So P, and it's AB by PQ. So it has to be Q here, AB by PQ, and the third one R. Is the question clear?
Yes, ma'am.
So I hope you have written.
Yes, ma'am.
Yeah, see, in the question, it was actually given this thing that AB by PQ is equal to, AC by PR, but it was given to be equal to AD by PM, right? So that means SSS criteria was not fulfilled because this was median, AD by PM. Yeah, so at least the third side we need to show it is also in proportion, or at least one angle we require, because this much we already have. So SS is already given, clear? So we need one more thing. So we did angle A is equal to angle P. We proved it. So it becomes SAS criteria, and then the triangles are similar. Is that okay?
Yes, ma'am.
Okay, next question. I think the last, no, 1, 2 more are there. 15th. Okay. the vertical pole of length 6 meter cast a shadow 4 meter long on the ground. So you have a vertical pole, let's say somewhere, whose length is 6 centimeter. Cast a shadow 4 meter long on the ground. And at the same time, a tower cast a shadow 28 meter long. Find the height of the tower. So you have something, it's a vertical pole here, and then you have a tower also somewhere. Clear? So at the same time means at the same spot, this tower is casting a shadow which is of 28 meter long, and this vertical pole is casting a shadow which is actually from here to here, it is 4 meter long. Understood? It's meter or centimeter? Yeah, 4 meter, 28 meter, 6 meter. Okay, that's fine. This is also meter. Everything is in meter. Yes, Amna, in the question? Meter, meter, meter. Yes, find the height of the tower. So basically this height you have to find. Let me call it X. So that's the figure. I hope you are understanding the figure.
Yes, ma'am.
Okay, this is 6 meter. And from here to here, you have 28 meter. So figure is this, that this is a tower. This one is actually a tower, and this is a pole. And here at this point, the shadow is being formed. So from the tower to the point, like till where the shadow is formed, the length is 28 meter. From the pole, it is 4 meter long. The shadow is 4 meter long. You have to find the height of the tower. So like come back to similarity of triangle. How can I solve this question? Any idea what can I do here? If I give some name, let's say ABC. Okay, this also I give some name. Then what will I do now? I want to find X. How can I find it? Yes, Rida, any response? How can I find it? See, it's so simple. Look here carefully, both of you. See here. You have two triangles, right? Let's say this is your one triangle. Yes, Rida?
Yes, ma'am.
Okay. And then you have another triangle. Yes, Hamna?
Yes, ma'am.
So if you can show this small triangle to be similar to the large triangle, let's say this is ABC and DE. Sorry, this is D, this is E. So if the two triangles are similar, I don't know how they will similar, but let's say they are similar. So ultimately what I'll get here, I'll get corresponding ratio, sides are in ratio. So I can get here, because I want to find X, X lies here. So I'll take AB divided by DE. Is that okay?
Yes,
And
ma'am.
because this side is known, so I can take this one. So I'm taking AB, so I'll take BC, and then I'll take EC. All right?
Yes, ma'am.
Yes. Now only AB you don't know. DE you know, right? 6 meter. BC you already know, 28 meter. And DEC you also already know, 4 meter. You can find AB. Yes. So let us try to prove the two triangles to be similar first of all. Then we can do it very easily. So in triangle ABC and triangle DEC. Now quickly tell me, what can I use here? Which similarity? Please unmute your mic, both of you.
AA similarity.
Okay, which angles are equal? Tell me.
Angle B is equal to angle E.
Why?
90 degree.
But how can you say it is 90 degree?
Ma'am, because it is given that it's a vertical pole.
Exactly. It is given in the question that it is a vertical pole. Vertical means it is standing at line 90 degree, you know, straight. Okay. Okay, you are right, but you have to see carefully. So, all right. So angle ABC basically is equal to angle DEC, both 90 degree.
Ma'am, angle C is common.
Angle C is common. Very good. So therefore, the triangles are similar. ABC is similar to triangle DEC. Okay. And because they are similar, now the sides are in proportion and obviously by AA criteria. So therefore, now you get AB upon DE is equal to BC upon EC. Now put the values here. So X upon DE is 6 meter. Now please check, units have to be same. So everything is in meter. It is given in the question. Is equal to BC is 28 meter and EC is 4 meter. So here the meter will be gone. So X will be 28 divided by 4 into 6 meter. Okay. Now check it. So 4 into 1 and 4 into how much? 7. And 7 into 6 is how much?
42.
42 meter. So 1 meter will come here. So that is the height of the tower, right? So you can write height of the tower is 42 meter. Okay, last question. So only 6.3 is coming in the exam, right? You know, 4 and 5 are not coming.
Yes, ma'am.
Yeah. Okay, next. Okay, last question now. 16th. If AD and PM are medians of triangle ABC and PQR again, so draw two triangles first of all. ABC and PQR. AD and PM, okay, again, median. So AD and PM. So median means it is given in the question that your BD is equal to DC and QM is equal to MR, right? Where triangles are similar, okay, it is also given that triangle ABC is similar to triangle PQR, and you have to prove that AB by PQ is equal to AD by PM, okay. So it's better if you mark, you know, AB by PQ. That means this side you have to show to be, okay, proportional to this, okay. And then you have to show AD, this proportion to this, right? So that means these small triangles you can show similar. So this time the full complete triangle is given to be similar. Now you can show the smaller one to be similar. So any idea how can we do this? Please think about it for a minute. Any idea?
Ma'am, angle B is equal to angle Q because the triangles are similar.
Okay, so what will it give me? Okay, why I'm taking angle B is equal to angle Q? I mean, what exactly I'm trying to do? Tell me that.
Ma'am, we need to prove that. Okay.
Yes, Rida, are you there?
Yes, ma'am. Ma'am, AB by PQ is equal to BC by QR is equal to AC by PR. plus CPST.
Yes, yeah, okay, corresponding parts of similar triangles. See, ultimately, first of all, it is important to make clear in your mind what exactly you have to do. Yes, Hamna? So now see here, basically you are trying to show this small triangle to be similar to this small triangle. Yes? Okay. So to show similarity, you have three criteria. Just, that's the approach. You have three criteria, AAA, SSS or SSS. Clear? Now it's very difficult to show all the three angles to be equal. So I think this will rule out, right? So we will see what we can do here. Now we make use of the given condition always. So it is given, like, let's do the proof. So if it is given that triangle ABC is similar to triangle PQR. So this is given. So that means all the sides will be in proportion. So I can write AB by PQ is equal to BC by QR is equal to what else? AC by PR. So this is given, right? Now look at my small triangle. So AB by PQ. So one side is corresponding side is equal. If I look at the small one, this one, clear? AB by PQ. Then I have, okay, AC by PR is not the part of the small triangle now. Yes, Rida?
Yes, ma'am.
So this is of no use. Now I make use of this one BC by QR because at least two sides I need in proportion. Isn't it, Hamna?
Yes, ma'am.
So I can convert this BC by QR into BD by QM by making use of this given condition. Yes?
Yes.
Okay. So can I write it like this? AB by PQ is equal to, if I write half of BC divided by half of QR, any problem? No. I'm taking these two only because this is of no use to me. It's outside the small triangle. So this side is not used to me. Now AB by PQ will be equal to, what is half of BC now? BD, which is actually a side of the small triangle now. Got it? And half of QR, I can take QM. Yes? Now you look at your small triangle ABD and PQM. So two sides are in proportion. So at least one angle I need to be equal. Now which angle I need, can I take equal?
Angle B is equal to angle Q.
Exactly. So from here, when I was writing this, so here only I can mention that also angle B is equal to angle Q. This is, corresponding parts of similar triangles. Understood? So, okay. So now take your small triangle. So in triangle ABD and triangle PQM. Now see what do I have now? So now I have AB by PQ is equal to BD by QM. All right. And I also have angle B is equal to angle Q. So by which criteria? SAS criteria. These two triangles are similar. So ABD will be similar to triangle. Now angle B is equal to angle Q and AB by PQ. So P has to come here and then PQM. So SAS criteria, these two are similar. Right? Now, when the triangles are similar, that means their corresponding sides are in proportion. So therefore, you can write AB by PQ is equal to AD by PM, the third side. Any confusion in this question?
No, ma'am.
Okay, please write it clearly. I've messed it up a little bit. Okay, Hamna, do you have any upcoming test now?
No, ma'am.
No, okay. Rida is having on 26th, so triangle is also coming. So please, yeah, tell me one thing. Have you visited your portal, both of you? Have you got the worksheet which has been uploaded on the portal?
I didn't get any worksheet.
So did you try to log into your portal, Rida?
Yes, I logged in.
Okay, then I'll check with the office, but they have informed that they have already uploaded it. You know, few days back I sent them. Anyway, I'll confirm with them. So you do one thing, uh, like today itself or might be tomorrow morning. Please check your portal because I'm going to send the worksheet of triangles also. So please,
Okay, ma'am.
yeah. So please download both. One actually was of linear equation, worksheet one. Initial two exercises, I think, based on initial two exercises only. So I'll upload more worksheets. And now for triangles also, I'm going to send you, please do all the question and then you have to submit the solutions. At least you will send me the picture of the complete solution. So you have to complete your worksheets. Okay, Amna?
Yes, ma'am.
Yeah, please confirm with, like contact the office in case you are not able to log in or any problem. Please contact Learnivio office for that. So I think coordinate geometry I am going to start. I think I should take a test in the next class. Is that okay? Can I
Yes.
take a test of
Which
triangles?
chapter?
Triangles, because we have just done it.
Okay.
Okay, ma'am.
Yes, is that okay? Both of you.
Yes, ma'am.
So on Tuesday, so you have like 2 days. So please prepare triangles. So Tuesday you will be having a test of triangles. Please note. And I'll personally send you a message that what type of test is going to be there, MCQ or subjective. If it will be a subjective test, so you will like join the class and you have to be honest because the test is for your benefit. Okay. So please don't open any kind of book or notes. Please try to solve the questions on your own and on time. Send me the picture. Don't be late. Whatever time is mentioned on the test, just after that time, whenever you start and whenever you finish, please send me the picture. Do it honestly. Okay. All right, then that's it for today. Tuesday you are having test and then I'll start with coordinate geometry.
Okay, thank you, ma'am.
Okay, bye. Thank you. मतलब आपने टाइप करवा के अपलोड किया ना बट स्टूडेंट्स को मिल नहीं रहे हैं वो मतलब लॉगिन किया है तो मुझे कह रहे कि देयर इज नो वर्क तो आपकी स्टूडेंट से कंप्लेंट करके अपलोड कौन करता है आप आपका क्या नाम है मैं मतलब अभी नहीं आपका क्या नाम है मैं बात कर रही हूँ वो आप हाँ अच्छा वो दूसरे आ रहा है आप उनका नंबर प्लीज मेरे साथ शेयर कर दीजिए, मैं उनसे बात कर लूँ। हाँ, वो मुझे कंफ्यूजन हो गया, मुझे लगा आप ही आ गए। चलिए फिर भी मैं एक बार उनसे बात कर लेती हूँ। हाँ हाँ, मैंने बच्चों से पूछा है तो वो कह रहे हैं कि नहीं है, तो इसलिए ठीक है। हाँ ठीक। Hello, Sarah. Can you hear me?
Yes, ma'am.
Oh, sorry, you didn't join. Actually, you were late. So I just thought you will not join. I didn't see
I
you.
actually forgot.
So when did you join the class?
7:12, I think so.
Okay. All right. So something we can do.
Yeah.
Yeah, actually, you were not in time now. So I thought actually you will not join. So I actually did so my laptop. Okay. So what were we doing in the last class, Sarah?
The question number 5th.
Of exercise?
No, 6th question.
Which exercise, Sarah?
Exercise. Which chapter is it?
6.2 or 6.3 we were doing?
6.2.
6.2, right. Just a minute. Sorry. Just a minute. Let me open my exercise.
Okay.
Yes, 6.2, question number 5. Have we done? Question 5, I think we did.
And we did 6th also. Now we have to
Six.
do 7th.
Okay, 7th. All right. So question number 7 means using theorem, that means BPT, right? BPT is talking about prove that a line drawn through the midpoint of one side of a triangle. Okay, so let us draw a triangle first of all. Let me call it ABC. Prove that a line drawn through the midpoint of one side of a triangle. So I'm taking midpoint of one side. Let me call it E, right? So I'm drawing a line through the midpoint and parallel to the third side. And I have to show that this line, sorry, F. So this line also bisects the side AC. I mean, F is also the midpoint of AC. Understood?
Yes, ma'am.
Okay, so what is given in the question? This is actually midpoint theorem. This statement of the question is actually midpoint theorem. You have studied this in class 9th also.
But can you
So
tell again?
yeah, so the question, right, that a line drawn through the midpoint of one side of a triangle parallel to the another side bisects the third side. It is actually called midpoint theorem, right?
Yes, ma'am.
Midpoint theorem. So this question is actually a theorem. You can write with pen some on the question, you can write on the side. This question is actually your midpoint theorem, right? Okay. Midpoint theorem, again, understand what is the theorem. So if you have a triangle, right? Let's say PQR, any triangle PQR, and you take midpoint of side PQ, right?
Yeah.
And you draw a line through it. So the theorem is that if this line, for example, LM, so if this line is parallel to QR, right?
Yeah.
And L is the midpoint of PQ, sorry. So by the theorem, it says that M is also the midpoint of PR. So that's the theorem. Got it?
Yes, ma'am.
The same thing we have to show in this question, that E is the midpoint of AB, and we have to show that F is also the midpoint of AC. But we will do it with the help of basic proportionality theorem, because in class 9th, we did the proof differently. Now we have already learned basic proportionality theorem, so we will take help from it. Okay. So it is
Yes,
given
ma'am.
that D is the
Midpoint of AB and
midpoint of AB, right? And also it is given that the line, sorry, EF is parallel to BC. Clear?
yeah.
Okay. What you have to prove? You have to prove that F is the midpoint of AC. Clear?
Yeah.
Okay. Now we start with the triangle proof. So we take triangle, sorry, in triangle ABC, right? If the line, sorry, if this line EF, I've called it EF, is parallel to BC. So I can use basic proportionality theorem now, right?
Yeah.
Okay, so by BPT. Now, since you can write, since the line is parallel to BC, so by BPT, your AE upon EB will be equal to AF upon FC. Is that okay?
Yeah.
Okay. Now, but it is given in the question that D is the midpoint of AB, right? So basically, it is given that AE is equal to EB. This is given.
Yeah.
Yes. So we will make use of it. So we will like AE we can replace by EB. So this will become EB divided by EB is equal to AF upon
Can
FC.
you say again?
Yeah, see, I've got this result, right?
Yeah.
Now AE is equal to EB. So I can
Yeah.
change this AE. I can write EB in place of AE
Why?
because both are equal.
Yeah.
AE is equal to EB.
Yes.
I mean, I'm using this result here, right?
Yeah.
So this will become EB by EB.
Hmm.
You can replace EB also, you can replace AE also. That's your choice. Both are equal. So this is 1 upon 1, right? They will actually, cancel out 1 upon 1. So ultimately you will get, so 1 is equal to AF upon FC. Clear?
Yes, ma'am.
Okay. Now you can cross multiply. So this FC will come here. FC is equal to AF.
Yeah.
Yes, any problem?
Yeah.
Okay. And now look in the figure, FC is equal to AF. Therefore, F is the midpoint of
Midpoint. Yeah.
AC. Simple.
Yeah, it's not that big.
Yeah. Now question number 8 is actually just a reverse of this question, right?
Yes, ma'am.
So just note it down. I'll hear to question number 8 also. So I'm using the same figure for question number 8. Now this time what is given? In question number 8 is given that using converse of BPT, right? That is theorem 6, the theorem you have written in your book. Prove that the line joining the midpoint of any two sides of a triangle is parallel to the third side. So it is given that D is the midpoint of AB. It is also given that F is the midpoint of AC. Clear?
Yeah.
So this time it is given, and this time you have to prove that your line EF is parallel to BC. Understood?
Yeah.
Okay. So just the opposite of it. So this is again simple. This time you will use the converse because the lines are given parallel. So obviously converse of BPT you will use. No, sorry. Line you have to show parallel laws. I'm sorry.
We are using the same triangle, right?
Yes, same figure, same diagram.
In triangle ABC.
No, start from here. Start from the given condition that D is the midpoint of AB, right?
Yeah.
Midpoint of AB. What does it mean? It means that AE is equal to EB. Clear?
Yeah.
Okay. So if I just divide this, so it become AE upon EB is equal to 1, right?
Yeah.
Like I bring this in the denominator. So here you will be left with 1. Okay. And okay, I'm just erasing a little bit from here.
Now you can erase it.
What are you saying, Sarah?
You can raise them down.
Okay. Right. Now come here. So this is like market 1. Now again, the second condition that F given condition, F is the midpoint of AC. So this means that AF is equal to FC. Clear?
Yeah.
So I can bring this FC in the denominator. AF upon FC is equal to 1. Mark it 2. Now if I compare 1 and 2, so RHS is 1 in both the cases.
Yeah.
So that means their left hand side is also equal. Yes, because both are equal to 1, that means they are equal.
Yeah.
So I can write that AE upon EB is equal to AF upon FC. Now I have got my sides are in proportion. Now see here, AE upon EB is equal to AF upon FC. So by converse of BPT, what is the converse? Okay, what is the theorem, Sarah? What is BPT?
BPT means when a line is drawn parallel to one side.
Yes, one line is parallel to the third side. Then
So to intersect the other side in distinct points.
that means, for example, EF is parallel to BC, right? That's the meaning.
Yeah.
So what does it mean? What will BPT say?
Yeah. AB
Hmm.
by AB is parallel to. No. AB is equals to AC.
Are you sure? AB is equal to AC?
EF is parallel to BC.
That is fine. There is a line which is parallel to BC, right?
Yeah.
Then what basic proportionality theorem tells you? What does it mean? What does it imply? See, if still the theorem is not clear in your mind, how will you do questions, Sarah?
No. AE is equal AE by EB equals to AF by FC.
Okay, now tell me in your words. Just forget about ABCD. In words, you tell me what is the theorem. In your own words.
Like here, we have to see like EF and FBC that they are parallel, right?
Yes.
So, we have like these what do we call them? Sides like AE and AEB and AFC. So,
they are in proportion.
yeah.
Okay, so that's the theorem that if this line is parallel, if EF is parallel to BC, then the other two sides are going to be in proportion.
Yeah.
Okay, that's the theorem, simple. Now, what will be the converse of this theorem?
That if like AE by EB is equals to AF by FC, it will equal to EF by BC. I mean EF parallel to BC.
Exactly. So if the theorem is line is parallel, then sides are proportional. Converse is sides are proportional, then line is parallel.
Yeah.
Just the opposite. Okay. Please, this has to be very clear in your mind. What is the theorem? If you know the theorem, converse you can write. So this time the sides are coming in proportion. So converse means that the line EF is parallel to BC.
Yeah.
This was we need to prove. It's very simple, Sarah. Like once, close your eyes, okay, and imagine the theorem in your mind. So you will never forget it. Do it that way.
Yeah.
Just try to speak up in your own words and imagine the diagram. Closing your eyes, just imagine a diagram. Then try to understand what is the theorem.
Yes, ma'am.
Have you written, Sarah?
I'm just 1 minute.
Okay. Just give me a minute. Yes, hello, Sarah. Have you done?
Yes, ma'am.
Okay. So next question now. Okay, what is the question? That ABCD is a trapezium. So you draw a trapezium, ABCD. So anywhere you can take ABCD, I take it like this, ABCD, right?
Yes, ma'am.
In which AB is parallel to DC. So this is given here that AB is parallel to DC. And its diagonals intersect each other at point O. So you have to draw the diagonals also. This is O, right? Show that. Now you have to show AO upon BO is equal to CO upon DO, right?
Yes, ma'am.
Okay, proof. Now look in the figure, what is AO, what is BO? So AO, BO, right? CO, DO. I
Yeah.
think it's clear. Okay. Now, Sarah, because I want to use basic proportionality theorem here. So, if I take, for example, I take this corner triangle. So at least I need a parallel line here. Then only I'll be able to use BPT. So I'll do one construction. Before the proof, I'll do one construction. So I'm drawing a line. For example, here I'm drawing a line. Let me call it E, A, B, C, D, E, right? So I'm drawing EO parallel to AB, sorry. That's my construction.
Okay.
Right. Now I'll do the proof. Now see, Sarah, because I have drawn a line parallel to here, right?
Yeah.
So which two triangles I should take? Like one time I can take this triangle, which is called ADC, because I have a line parallel here, right?
Yeah.
So I can use BPT. Then the other time I can take this lower triangle because EO is also part of this. I can take this. Getting the point?
Yeah.
So I'm in the left side, both the triangles I'll take. One's the top one, one's the bottom one. Understood?
Yeah.
Okay. So let's take the top triangle in triangle ADC. Now, if I take the top triangle ADC and EO I have drawn parallel to AB. So I think I should take the bottom one first. Okay. Oh, can you see the triangle ADC in the figure, Sarah, clearly?
Yes, ma'am.
Okay. Now see here, I have two things here. EO is parallel to AB actually, right?
Yeah.
Okay. How? Like by construction. Okay. And it is already given that AB is parallel to DC. This is given. So from these two, can I say my line EO will also be parallel to DC?
1 minute, let me see. Yes, ma'am. I think so. You can.
Okay, now try to understand one thing, Sarah. When I'm drawing the line EO, right? So I cannot take like this that EO is parallel to AB is also parallel to DC. I take only one, whether I'll take EO parallel to AB or I'll take EO parallel to DC. That's it. Why? Because if I take this EO parallel to both the lines, so ultimately, uh, okay, this is the reverse. It is already given. Yeah, that it doesn't matter. Okay, wait. I think in the next question you cannot do that, but here you can do. Okay, anyway, EO is parallel to AB. So from here, I can take EO. I conclude that EO is also parallel to DC. Is this okay?
Yes, ma'am.
Okay, see it again. You do one thing. You take EO parallel to AB and also parallel to, wait. Okay, fine. Take EO parallel to AB. Now see here. EO is parallel to AB, right? And AB is parallel to CD. So this implies that the line EO will also be parallel to CD. Is that okay?
Yeah.
Yes, it's actually a theorem. So in class 9th, you have studied that if you have 3 lines, right?
Yeah, ma'am.
This is line 1, this is line 2, line 3. For example, if line 1 is parallel to line 2 and line 1 is also parallel to line 3. So this implies that line 2 is also parallel to line 3. All right.
Yes, ma'am.
So we are using the same thing here. That AB is also parallel to EO and AB is also parallel to CD. So that means EO is also parallel to CD, right? Now you come here in this triangle. So in triangle ADC, right?
Yes, ma'am.
So I can write ADC means DE upon EA is equal to OC upon OA. Is that okay? Or you
Yes,
write
ma'am.
like this? Write like this, CO
CO.
upon DO, like just to make same, CO upon DO, right?
Yeah.
Okay. Oh, wait, before this, I have not written that since the line EO is parallel to CD, so this you can write by BPT. Now come to the lower triangle. So in triangle DAB, the lower one, right? Again, EO is parallel to AB. Fine.
Yes, ma'am.
EO is parallel to AB. See the figure. So what can I write this time?
One minute.
So if I write DE upon EA equal to, what should I write now?
A AO.
No. I'm taking, first of all, Sarah, I'm taking this triangle, this triangle, right?
Yeah.
Okay. So in this triangle, like this line is parallel to this line. Understood?
Yeah.
Okay. So that means the sides are in proportion. The other two sides are in proportion. So if I'm taking DE upon EA, so this side, what should I take?
DO upon OB.
Exactly. DO upon BO, right?
Yeah.
OB or BO, same thing. So this is obviously by BPT. So this is equation 2 and this was your equation 1. Now you compare 1 and 2 from equation 1 and 2. Is there anything which is same here?
DE upon EA.
Yes, so left hand side is same. So that means the right hand side is also same. So CO upon DO is equal to
DE.
somewhere I've written something wrong. CO upon AO. This was AO, Sarah. if you look carefully, the top triangle. So DE upon EA should be equal to CO upon AO. Yes?
Yes, ma'am. Yeah.
Yeah. So CO upon AO is equal to DO upon BO. Now just see what you have to show. Look here. So you have to show AO upon BO. So you can just first of all do cross multiplication. You can take like BO this side. Can I write it like CO into BO divided by AO is equal to DO? Yes.
Yeah.
And I can bring this CO here in the denominator. For example, I have 2x is equal to 4. So where this will 2 will go? Here in the denominator, x will be 4 by 2. Same way. So it will be BO divided by AO is equal to DO divided by CO. So CO will come in the denominator, right?
Yes, ma'am.
Now you can flip the equation because you want AO by BO, right? So you can write AO by BO. So this side also you will flip. So CO by DO. So that's what you were supposed to prove. Yeah, done, Sarah?
No, ma'am. I'm done.
Okay. Now see the next question again. The next question is, opposite of this question. Please read the question in your book.
The diagonals of a quadrilateral ABCD intersect each other at a point of 4. Says that 4A by 2O is equal to 2O by 3O. So that ABCD is equal to C. Okay.
Yeah,
we
just
have
a
to
minute,
show here
Sarah. Yeah, so this is just the inverse. Yes, Sarah, sorry. Next question, number 10.
10.
So the question says the diagonals of a quadrilateral ABCD intersect each other at point O. So you take a quadrilateral. Okay, let me use the same figure. What I had marked here, ABCD in the last question, right?
Yeah.
Okay, ABCD, all right. So then there are diagonals here. Please draw it properly anyway. O. Now this time it is given something is given. So the result is actually given this time. So AO upon BO is equal to CO upon DO, right? So the result
Yeah.
of the previous question is now given. And you have to show ABCD is a trapezium. ABCD is a trapezium. Okay, what is the definition of trapezium, Sarah? What is a trapezium?
It's a quadrilateral.
Yeah, obviously it's a quadrilateral. It has 4 sides, but what are the properties? I mean, square is also quadrilateral, rectangle is also quadrilateral. So what is special about trapezium? See, you should know this. Then only you will be able to say what exactly you have to prove, right? Okay, think about it. Take a minute. Yeah, Sarah, what is special about trapezium? See, square means, are you there, Sarah? Please unmute yourself. Okay, I'm not able to hear you. Sarah, please speak up. No, I cannot hear you.
Can you hear me now?
Yes, now I can hear you.
Okay.
So Sarah, yes, say.
That maybe because it's having a parallel sides, like the is parallel to B.
Yeah, trapezium is actually such quadrilateral in which one pair of opposite side is parallel. Okay.
Yes, ma'am.
So this AB is actually parallel to CD. And obviously because the shape is like this, so these two lines are not parallel, you can see, right?
Yes, ma'am.
Yeah, so any one pair of the opposite side has to be parallel. That is called a trapezium. So if you are proving that ABCD is a trapezium, so actually, you know, that is, you have to show that AB is parallel to CD. This is what you have to show.
Yes.
So again, you will do one construction here. Now construction will be, you can take a side, again, you can draw like this, mark it E. So EO is parallel to any side you can take. Let's take AB. Now, important thing here is I cannot take EO parallel to AB and also parallel to CD. I cannot do the construction like this. Why? Because ultimately this thing I have to show. If I'll draw it in the construction, then what is the point of the proof, isn't it?
Yes, ma'am.
So only one side I'll take to be parallel. The other one we are going to show that it is also parallel. So because I have taken AO parallel to AB. So which triangle I can start with?
A ADC.
See, AB.
ADB.
ADB. Good. So proof. Now in triangle ADB. Okay. Now since EO is parallel to AB. So from BPT, what can I write?
That AE by ED. Can you hear me?
Sorry, yes. AE by ED
Is equals to 1 minute. Yeah. BO by DO.
BO by DO. Yes, okay, that's good. So mark it 1.
Yeah.
Right.
By BPT.
Okay. Now something is given to me. So this is given that AO by BO is equal to CO by DO. This is given, right?
Yeah.
Now this side I have, you can see BO by DO. So I want to make it same. So what will I do is I'll take BO this side and I'll bring CO here. So I can write it AO by CO is equal to BO by DO. Any problem?
No.
Okay. Now from 1 and 2, what can I write?
1 minute.
No, not
That-
1 and 2. No. Wait. Because I want to show the line is parallel. So 1. Oh, yeah. Okay. First I'll write. Yes. Okay, Sarah, tell me what can I write? I can write AE upon ED is equal to AO upon CO. Yes.
Yeah.
Because BO upon DO is there in both the equations.
Yeah.
Okay. See, ultimately I want to show AB parallel to CD. So which triangle I have to use now? Sorry, I have to show that EO is parallel to CD also. This I have taken in construction. Now I want to show that the line EO is parallel to CD. So which triangle I should use?
No. DBC.
No. EO is here. EO. And I want to show it parallel to this side. So which triangle I have to take?
No.
Okay, wait.
Yeah. DAC.
Look here. What is this? AE upon ED, right?
Yeah.
AE upon ED is equal to AO upon OD. Sides are in proportion. So which theorem I should use? By converse of BPT?
Yeah.
What can I write? Which line is parallel to which line?
That EC is parallel to DO.
EC. EC is not a line. Okay, Sarah, look here again very carefully. You have this AE upon ED, right? AE upon ED, right?
Yeah.
Equal to AO upon OC. That means which triangle is he talking about? In triangle, which triangle I should write? The sides are proportion. Which triangle sides are proportion? ADC.
ADC.
Yes. Yeah. So
Yeah.
in this triangle, now I have AE by ED is equal to AO by CO. So that means by converse of BPT, my side EO is parallel to CD, isn't it?
Yeah.
Yes.
Yeah.
So simple.
Yes.
Okay. Now use these two results. So one is this by construction and sorry, 1 not 3 and this 4. You can give any name. It doesn't matter that you are giving, 3 in the starting. It's just a name of the equation. It's not a sequence like serial number. It's just a name. So now from equation 3 and 4, So
Right.
you have, yeah, you have EO parallel to AB and you have EO parallel to CD. So this implies that AB is parallel to CD.
Yeah.
And therefore ABCD is a trapezium. Understood?
Yes, ma'am. I'm kind of confused, but I will see it afterwards.
Yes.
Again.
Sorry, what are you saying?
I'm a little confused, but I will see it afterwards again.
Should I do it again, this question?
Yeah.
Okay, let's do it again, no problem. Just a minute. Use a trapezium first of all. And draw the diagonals. This actually is simple. You just got a bit confused. So A, B, C, D. Right? This is O. Okay. So it is given this time, whatever given right now, it is given AO upon BO is equal to CO upon DO. And you have to prove that ABCD is a trapezium, so, right? So ultimately
Yeah.
you have to show that AB is parallel to CD. That's what you have to prove, right?
Yeah.
That's the definition of trapezium. So we will do one construction here. So we draw a line EO. So draw EO parallel to AB. Clear?
Yeah.
Or CD also you can draw, no problem. EO parallel to AB. Okay. Now you see this triangle. In triangle DAB, the top one. See the triangle DAB.
Yeah.
Okay. Now because EO is parallel to AB, so you can write, that means by BPT, the sides are in proportion. So DE upon EA is equal to DO upon BO. Is this okay?
Yeah.
So mark it 1. All right. Now you combine this with the given condition. This is given that AO upon BO is equal to CO upon DO. Right?
Yeah.
Okay. Now because you have DO by BO here, so you make it here, same. So take this BO there and CO here. Clear? So this
Yeah.
is AO upon CO is equal to BO upon DO. Now again, DO in the denominator and BO in the numerator. So you can just flip it. No problem. You can write CO by EO is equal to DO by BO. Any problem here?
No.
Because ultimately I want to make this thing equal to this thing.
Yeah.
So I have simply rearranged. That's it. So this is 2. Now combine 1 and 2. So from 1 and 2, what I'm getting? Left
DO
hand side.
by BO.
No. DO by BO is same in the both. So that means DE by EA is equal to CO by AO. Yes.
Yeah.
I mean, the LHS is same now because
Yeah.
RHS is same. Okay. Now I use this result. So just see in the figure, what is DE, what is EA. So DE by EA is equal to CO by AO. Yes.
Yeah.
So
So
what?
DAC triangle.
Yes, in triangle DAC. So I'm getting DE by EA is equal to CO by AO. So what does it imply? That means by converse of BPT, the sides are in proportion. So converse of BPT,
Yeah.
my line EO is parallel to CD. Yes.
Yeah.
So that's what I was supposed to, I was trying to find out. Now this is one, you can call it something, equation X and call it equation Y, right? No problem. It's just a name of the equation. Now you combine X and Y. So from X and Y, equation X and Y. All right. So you have EO parallel to AB from X and then EO parallel to CD from Y. So this implies that AB is parallel to CD. Understood?
Oh, it's a tricky. Yes, ma'am.
Sarah, have you received the worksheet on the portal? Have you tried to download?
Yeah. I tried, but I couldn't download it. I was like clicking it again and again, but it wasn't coming.
Okay, then I'll check with the office, and I'm going to upload a worksheet of the triangle also. Might be, today itself or tomorrow morning. So please tomorrow check your portal.
Okay, ma'am.
Based on some initial, or I think I should complete the chapter first and then I'll upload. That will be better.
Yes, ma'am.
Anyway, I'll upload because in the other batches, it's already complete. So you can just try initial questions, at least you will be able to do. Just keep on doing. Okay. And yes, Sarah, you told me that you are using together with, right? Together with mathematics. So actually just do it carefully. There are a lot of printing mistakes in that book. So don't just blindly follow it. Sometimes there are mistakes. I've just seen that book. Some mistakes are there. So, okay, then.
So should I take any other book?
No, book is good. I'm just saying somewhere, in place of ACD, for example, ABC is written. So you have to be a bit careful. I mean, use your own mind, right?
Yes, ma'am.
Sometimes a slight little mistake might be there. So just do it carefully.
Okay, ma'am.
Okay. Book is fine. Book is no problem with the book. Questions are fine. Okay. All right, then we will meet on Tuesday. We will try to complete triangles then.
Yes, ma'am.
Okay, then. Thank you, Sarah.
Ma'am, I'm not finished.
Oh, sorry. But
I'll
just a
just take
minute.
the screenshot.
Wait. Yes, it's here.
1 minute, I'll take screenshot. Yes, done.
Okay.
Yeah, ma'am.